Now let's do another one-tailed test, but in this case we'll look at our proportions test. A television manufacturer had claimed in its warranty that in the past only 10% of its television sets needed any repair during their first 2 years of operation. In order to test the validity of this claim, a government testing agency selects a sample of 100 sets and finds that 14 sets required some repair within their first 2 years of operation. Using an alpha of 1%, is the manufacturer's claim valid? Alright, so what we have is a claimed value, 10%, and then sample data, 100 sets is a sample size, 14 out of the 100 would be a sample proportion, which would be like 14%, and we want to know if the 14% really is out of sync with the claim of the 10%. So the first question really is this really a one-tailed test? And it's not, the wording is not as clear as it could be. It says that in the past only 10% of its television sets. Now the only means that it could have been larger, but it's not. It's 10% or smaller. Or in other words, the statement should have been something like, at most 10% of its television sets needed any repair, and that's a one-tailed test. Alright, so we're going to do a one-tailed test against the 10% value, and we've got a sample value of 14 out of 100, 0.14 or 14%. Check it against the 10. Alright, so let's write down our sample data. So I should always do that. N is 10, and our sample proportion P hat is 14 out of the same N, 100, and that's 0.14 exactly. And our claim, reworded, is that at most 10% required any repair. Alright, so this is a one-tailed test. It's not, is it exactly 10% or is it something other than 10%? So it's a one-tailed test. And the very next thing we're going to worry about is which tail. So we can write down our hypotheses. To do that, we figure out if the sample value is going to be in the upper tail or the lower tail. And you can visualize it in your head, or you can use the similar process as we did with averages. P hat, in this case, 0.14, is greater than the 10%, with 0.1, and so greater than tells us that we have an upper tail test. In other words, the sample value will be in the upper tail, and we want a critical value up there also to make it sort of a sporting thing. And now we want to write down the alternate based on that. We have that P hat is greater than 10%. Change the P hat to the population equivalent. The question is P greater than 10%? Okay, that's the way we set up our hypotheses. Let's now write down both hypotheses. Null hypothesis, and actually let's write down the alternate first since we already have that. P greater than 0.1, and so the null will be P less than or equal to 0.1. P is less than or equal to 0.1, the claim is valid, and alternatively then the claim is not valid if the sample proportion is greater than 10%. Remember, in your statements here, what you want are accurate statements without any probabilistic feel to them. These are precise statements. these in the decision rules, and in the decision rules we're going to say it's possible claim is valid, and for the alternate we can, for the second part of the decision rule, say it's likely the claim is not valid. If these statements here involve weak words, then we're going to have double up our weak words. We're going to say possible blah blah, and we have weak words again, so possible weak, or in other words also likely weak, or we don't want decisions here. Right? We're going to say possible that certain decision is made. No, we don't want to say that. We want to make a decision ourselves. Next step is to do calculations, draw a distribution. This now is the probability distribution sample proportions sampling distribution. The middle of this distribution is going to be the p.1. Remember, we're going to do an upper tail test here with an alpha given to us of 1%, so we're going to put 1% in the upper tail there and calculate that upper limit. What we need is the standard deviation of that distribution, sigma sub p hat, which will work out, and then we want also a z-value with 1% in the tail. Alright, so down here, let's calculate the standard deviation. So sigma sub p hat is the square root pq divided by n, or, which is exactly the same, p times 1 minus p on n. Alright, the p comes from the middle of the sampling distribution here, so that's 0.1 times q, or 1 minus p, the same thing, it's complement, it's 0.9, right, 1 minus 0.1 is 0.9, divided by sample size of 100, square root of the whole thing, and that's exactly 0.03. Alright, so we have the standard deviation of this distribution. And what we need now is the z-value. Let's swap over to the t-tables. Again, the last line is for the z distribution. We want 1% in the tail, so the value is 2.326. So the z-value that gives us 1% in the upper tail, 2.326. And now we're ready to calculate that upper limit. So let's just call that UL for short. It'll be the middle of the distribution, as we had for averages, plus the z-value with alpha in the tail, times the standard deviation, sigma, so p hat. Alright, for this particular case, that's 0.1 plus 2.326 times 0.03, and after calculating that out, we get a number on our calculator, 0.16978, and to 4 significant places, that's 0.1700 if you like, or essentially 0.17. So if the manufacturer's claim is valid, that the true proportion is at most 10%, then it's most likely that our sample proportions will be somewhere less than 17%. It's unlikely, if the claim is valid, to get values up here. So if we get values up here, we must say that it looks that the claim is not valid. So what we have now is our distribution, upper limit of the acceptance region of 0.17. So on the basis of that, we're going to write down our decision rule. Alright, so first for the acceptance region where the alpha is not. So if we get a sample value p hat in the acceptance region, which is less than or equal to 0.17, null is possible. So we say do not reject the null. Interpretation is possible. Null is correct. Switch back for a second and show you what we had for the null. It's possible, therefore that the claim is valid. Alright, so if you get a sample value less than 17%, we're in the realm of normal sampling error for the claim to be possible. Alternatively, we get where p hat where the alpha is, so if p hat is greater than 0.17, now we have a sample value too far away from the hypothesized value, so the null is unlikely. We reject the null and in its place, therefore we'll accept the alternate, and interpretation, it is likely. The alternate is true, it's likely the claim is not valid. Alright, and now we're ready to do our decision. Our sample value of 0.14 is well within the acceptance region, so we'll follow part 2 of the decision rule. So part 1 of the decision rule. Since p hat is 0.14, which is less than the upper limit of the critical region at 0.17, that means that 0.14 is in the acceptance region, it's in the realm of normal sampling error. We'll say do not reject the null. And follow along with the interpretation. It's possible the null is correct, or it's possible the claim is valid. And that's the end of this one-tailed test.